Welcome to Motorola Land Planner's demonstration video, which will provide an in-depth look at Land Planner functionality and usage. This software enables network planning teams to design Wi-Fi deployment strategies that are customized for their site. Each step of the process allows the user to adapt the design to meet their specific needs. This includes customizing the building model, choosing equipment, and predicting performance. Land Planner allows the designer to take the end-user equipment and applications into consideration and provides a full suite of measurement tools. Combining all these abilities into one piece of software, Land Planner users enjoy better performance by design. The design process starts with the building model. The software allows you to import raster images, CAD drawings, or draw freehand. The building lines are then formatted. This is accomplished by assigning partition types to building materials as appropriate. Land Planner comes with several predefined partition types which lend themselves to most common building structures. Most buildings can be formatted immediately with very little customization. However, for more challenging environments, partition types can be fully customized. Each partition type is assigned a name, color, and attenuation properties per frequency. During predictions, the RF signals react to these partitions, resulting in a site-specific building model. Land Planner allows you to import your building floor plan and obstacles into the software using AutoCAD technology. This makes the building model extremely accurate and flexible. If an AutoCAD drawing is not available, a raster image can be traced. Both workflows support multi-story facilities. Land Planner takes all access points on different floors into consideration during the design, thus minimizing interference while maintaining full RF coverage. Let's look at the AutoCAD workflow for building formatting. First, an AutoCAD drawing for the facility is obtained. This drawing will be flat and contain many layers, some of which will be converted to building partitions. Layers in the drawing are selected and are formatted by assigning a partition type and height. This is repeated until all relevant obstructions have been formatted. Only RF relevant obstacles such as doors, walls, and metal are formatted in the drawing. Some layers do not contain useful information, such as lighting and electrical displays. These are deleted. After all the layers have either been converted or deleted, the building model is complete. If anything in the actual building differs from the drawing, it can be changed easily. Walls can be added or removed at will. It is important to model the building as accurately as possible, as this will affect the RF predictions. Only obstructions that would affect the RF signal need to be modeled. For instance, cubicle walls would definitely affect the signal, but furniture is too low. As you can see, each partition type has a certain RF characteristic associated with it. Each piece of drywall has an attenuation of 1.5 decibels at 2400 MHz by default. This means that the RF signal from the access point will lose 3 decibels as it penetrates the wall, or about 1/2 of the signal. Different partition types can have different RF characteristics. The RF properties can be changed as well. Here, metallic obstacle is being lowered to 5 decibels attenuation. The partitions that come with Land Planner have RF properties that have been averaged. Through a process called optimization, these values can be fine-tuned for a specific building using measurement data. More on that later. The examples so far have used CAD drawings for the building model. If a CAD drawing is not available, a raster image can be traced. Land Planner simulates a light table, and the important structures in the image are traced. To the software, the resulting building model is identical to those that came from a CAD drawing. Partitions, floors, and RF characteristics are treated exactly the same. With either workflow, the drawing units can be specified, English or metric. Land Planner provides all the tools necessary to facilitate the building model process regardless of the source materials. The result is a three-dimensional, multi-floor building that is RF intelligent and can be fully customized. The building model complete, now we can place equipment. Access points can be placed, moved, or deleted anywhere in the building. Channels and power settings are easily modified to experiment with different what-if scenarios. Land Planner ships with all current Motorola access point and antennas ready to be used. In addition, Wi-Fi air standards are pre-configured to comply with regulations in most countries around the world. Here is an example of placing and editing equipment. The floor of this building will be covered using Motorola AP300s. Since this building is in America, the United States version is chosen, which complies with that country's channel and power regulations. Dropping access points is as easy as clicking the mouse. To be more thorough, a switch can be placed and cable runs can be checked with the measurement tool. Each access point is placed with default parameters, but they can be customized individually. Access point height, channel, and power can be adjusted. These access points were placed with the standard omnidirectional antennas. However, for this hallway, a directional antenna might make a better choice. The existing antenna can be replaced and then oriented in the proper direction. New antennas can be added in the parts list library and reused in future projects. The Omni antenna has been replaced with a directional panel and its orientation is indicated in the drawing. Along with Wi-Fi access points, Land Planner supports sensors as well as switches to assist with Wi-Fi planning. After equipment has been placed, RF predictions in the facility can begin. As with the building model process, care should be taken to place and customize equipment as accurately as possible, following real-world restrictions where appropriate. Land Planner RF predictions combine the RF intelligent building model and the Wi-Fi equipment to produce fast and accurate plots of predicted system performance. The software offers many distinct prediction modes that can be tailored to apply to a variety of scenarios. These prediction modes include contour, grid, instant point, and AP positioning. The results can be customized and viewed in many different ways. Running predictions allows the user to try many different equipment and placement scenarios before deployment. This information helps the user avoid multiple site surveys and costly redeployments. A Quick Start AP placement feature assists in large designs or bid estimates. Let's look at these features in detail. After access points are placed in the building model, RF predictions can be performed. Contour predictions are the fastest to run and give a good indication of system performance early in the design. Contours radiate from each access point and are colored by signal strength. The number of contours, signal powers to display, and colors can all be defined. A legend is provided which is automatically updated to match the contour configuration. Predictions can be run for one access point, all access points, or any combination. Even signal from a radio on a different floor can be displayed. Instant point mode provides a different kind of prediction strategy. Instead of displaying the prediction results on the entire drawing at once, this mode allows the user to see how all radios perform at a given point. This point can be moved anywhere in the building and is updated in real time. A green line indicates the path back to the current strongest radio. Contour positioning is the complement to instant point mode. Instead of moving the client, the access point is moved by the user. The contour boundary at a given signal power is updated in real time. In this example, that boundary is -65 dBm. This mode can assist with strategic access point placement, helping the user to get the most out of their equipment. Grid predictions are the most accurate and flexible offered by LANPlanner. After defining a prediction boundary, any combination of access points can participate. In this example, signal strength is plotted all the way down to the noise floor. However, a signal threshold can be used. Here, only signal better than -85 dBm is shown, giving a very clear picture of where the criteria is not being met. All of the signal levels and corresponding colors can be modified in the Color Scheme Editor. In addition to signal strength, many other grid plots can be displayed, including signal to interference, best channel, and service counts. This last plot indicates where there is redundant coverage. The prediction engine can also recommend access point placement based on criteria provided by the user. A service region for coverage is defined that includes signal level requirements, capacity, and applications. Exclusion regions are also accepted, letting the software know where equipment cannot be placed. Given these criteria, the software recommends access point placement and provides a brief summary. The various prediction modes offer many ways to assist in Wi-Fi planning. Contour and grid predictions allow the user to see predicted performance with various access point layouts. Contour positioning mode can help discover key access point positions that will provide the most coverage from each radio. Quick Start AP will make estimates to the amount of equipment needed given signal and capacity parameters. LANPlanner's predictive capabilities allow the user to create Wi-Fi designs that work the first time. LANPlanner includes a suite of built-in measurement tools that complement the building model and prediction functions. We'll look at that area next. Site surveys gather signal strength information from access points throughout the facility. The collected information can be presented in many different ways. Since LANPlanner is also a predictive tool, measurement data can be analyzed and used to fine-tune the building model in a process called optimization. In addition to traditional RF signal site surveys, LANPlanner can measure the actual network performance at the packet level, which is critical for applications such as voice over IP or streaming video. Let's start by looking at a traditional RF site survey. Using the building model as a floor plan, the user walks the facility with LANPlanner and takes measurements on a laptop. At each measurement point, RF data is collected including SSID, MAC address, and signal strength. Two different measurement modes are supported: RF monitoring and AP performance. RF monitoring mode requires a special Wi-Fi card, but channel scan time is controlled by the user, which results in a faster scan time and thus a faster site survey. With this mode, you can also obtain data about hidden or cloaked APs, and signals can be collected in both the A and BG bands simultaneously. For AP performance mode, any standard Wi-Fi card with a Windows driver can be used. However, scan time cannot be controlled, and each band will need to be measured separately. This mode also enables packet-level analysis. For some applications, the performance of the network at a packet level is just as important as the RF signal strength. Therefore, LAN Planner offers network performance measurement capabilities. A small application called SiteSpy is placed on the network and data is captured as packets travel to the measurement laptop. A variety of protocol options enables the user to simulate different applications. A site survey is performed in the same manner. However, network performance data is captured at the same time as signal strength. Real-time packet throughput, latency, and jitter are among some of the values that are gathered. Once the measurement data is collected, it can be represented in a number of different ways. Heat map visualizations provide an easy way to see measured performance throughout the facility. Data is organized by SSID and MAC addresses. Information can be shown for a single access point, by SSID, or all access points. In fact, with a strategic visualization, a rogue access point can be located. A heat map can represent signal strength, signal-to-noise ratio, channels, or other criteria. Exact signal strength readings from an access point can be plotted as well. LAN Planner can use measurement data to fine-tune the RF properties of a facility, resulting in a more accurate building model. Site survey measurements are taken from one or more known access points. The measurement data is then associated with these access points in the drawing. Given this, the software recommends new attenuation values that more accurately reflect the building materials in the facility. In this example, the optimized parameters show that the original prediction was a bit too optimistic. The optimization process is optional, but can result in a more accurate prediction. This might make a big difference in a large or complex facility. Next, we will look at LAN Planner integration with RFMS, the RF management software tool. Motorola RFMS is a browser-based visual management tool used to troubleshoot and monitor Wi-Fi deployments. Once a network has been deployed following the LAN Planner design, companies use RFMS to monitor and manage their installation. The LAN Planner design can be easily exported to RFMS and includes all of the equipment locations and RF intelligence. RFMS features a variety of key performance indicator graphs which display network health at a glance. Users can view the status of all wireless devices and clients. The impact of access point outage can be displayed with a heat map. Even users with little or no RF experience can manage their Wi-Fi networks with easy-to-use menus and icons. Combining the building and design tools in LAN Planner with the management and troubleshooting functions in RFMS results in a Wi-Fi network that is both correctly planned and effectively monitored. Thank you for viewing the LAN Planner demonstration. The wireless networks created with LAN Planner provide superior coverage, capacity, and overall quality of service for some of the most demanding applications, even in complex RF environments. For more information about this or other Motorola RF design and management products, please contact us using the information provided here.